Okay, so the case for catastrophism, as you can see, we are going to talk today about Mount St. Helens. But before we do, I want to explain what catastrophism is again. Catastrophism is the belief that the geological features of the Earth are best explained by a global catastrophe, of course, the one that is recorded in Genesis 7 through 9. So catastrophism, we need to review that. There it is again, the belief that the geological features of the Earth are more readily explained by catastrophic events, in particular, the Genesis flood found in Genesis chapter 7 through chapter 9. That is catastrophism. And this is in contrast to uniformitarianism. Basically, what is the phrase I want you to remember for uniformitarianism? Natural processes over what? Geologic time. And geologic time is code for millions and millions and millions of years. When we talked about fossil formation, we talked about requirements. What are the 3 requirements for fossil formation? The first is rapid burial. The second is a lot of sedimentation, a lot of sediments. We've got to have a source of minerals. And then we need high pressure to compact the sediments down so that we will get fossilization. What is not a requirement of fossil formation? Time. In particular, millions and millions of years. Time is irrelevant. We don't know exactly how long it takes fossils to form because it depends on the circumstances. It depends on the pressure. It depends on a lot of different things, one of which, of course, is not time. So we're going to use catastrophism to show that the flood, which is catastrophism, we're going to use the flood, and we're going to use the fossil record, and we're going to use geological processes to show that the flood is the best explanation for the fossil record. The flood is the best explanation for strata. The flood is the best explanation for the geological features of the Earth. Which geological feature of the Earth did we highlight earlier? Big geological feature of the Earth. Yes, the Grand Canyon. So we're going to go along those same lines today and show that catastrophism is a better explanation, especially when we look at a recent catastrophic event, which was, of course, the eruption of Mount St. Helens. I want to go over proponents again. You can see on, of course, your left, I guess that'd be your right, Henry Morris. Henry Morris, along with John Whitcomb, was the author of the book, The Genesis Flood, in the early 1960s. He is the founder of he was the founder of Institute for Creation Research, and he is certainly could be called the founder of the modern creation science movement. Okay. And then next to him is his son, John D. Morris, and then we have Andrew Snelling and Stephen Austin. John Morris is now semi-retired. He's the president emeritus of ICR, Institute for Creation Research. He is a geologist. He holds a PhD in geology from the University of Oklahoma. Then we have Andrew Snelling. Let me get control of the cursor here. There it is. This is Andrew Snelling. He's an Australian. He has a PhD in geology as well from the University of Sydney. So we've got scientists who are catastrophists. Many times, one of the criticisms of creationism is that everybody believes in evolution. All scientists agree on evolution, and that's simply not true. All right, so then the last person here is Stephen A. Austin. He has a PhD in geology from Penn State. He is a big proponent of catastrophism. In fact, most of what I'm going to tell you about Mount St. Helens is from the studies that he has done on catastrophism and his research, his direct research on Mount St. Helens. okay, and what that means for catastrophism. All right, so we're going to review again the debate, catastrophism versus uniformitarianism. There's catastrophism. I can't prove to you that the flood occurred because it's a past event, but what I can do is show you that it is the best explanation for the geological features of the earth. And I can show you that uniformitarianism fails as an explanation. So, the main thing that I want to show you about catastrophism is that the natural processes, of course that would be uniformitarianism, those natural processes are insufficient to explain the observable features on the earth. All right, and then uniformitarianism. Of course, another quote associated with the uniformitarianism is the what? The present is the key to the past. And their whole belief centers in on natural processes only over vast amounts of geologic time. So we're going to go back to prediction versus accommodation. And I want to show you that what we see on the earth is predicted by a global catastrophic flood. Whereas if we're talking about natural processes over geologic time, it does not explain many things that we actually observe on the earth. All right, today I'm going to talk about different things predicted by catastrophism and different things that have to be accommodated or explained away. So this part of the slide is different. All right, I'm going to review briefly what's actually in the fossil record. But now we're going to center in on other features besides the fossil record. The large areas of sediment, formation of strata, and even the Ice Age. The Ice Age is something that's been promoted and even a lot of entertainment involving the Ice Age. Is there proof that there was an Ice Age? Yes. All right, so what's the best explanation for the Ice Age? Global catastrophe or uniformitarianism? Okay, so all in all, I want you to remember that the Genesis flood is the best explanation, not just for the fossil record, but for many of the geologic features of the earth. So let's talk about the flood. What are the effects of the flood? What would be some effects of the flood? We would have massive, massive erosion, right? Then we have lots of water. So once those minerals would be eroded, they would be suspended in the floodwaters. So we'd have lots of sediment, and not only is the sediment there, it's going to be transported. It's going to be suspended in the floodwaters, and then it's going to be transported, carried all over the place. Another effect of the flood is deposition. As the floodwaters move, they're going to transfer minerals, but then as they evaporate and as the floodwaters leave the features of the earth, we're going to have more erosion and we're going to have vast amounts of sediments being deposited. Compaction. Moving water exerts massive amounts of pressure, especially when we're talking about the volume of water of a global flood. So all of these effects here on this particular slide, we're talking about effects of the water. But keep in mind that the flood was much more than the rains came down and the floods came up. It was much more than that, a lot more than that. The flood was a catastrophic global event. Okay? So there are other effects of the flood, not just the ones that we mentioned with fossil formation. All of those things, the erosion, the sediment, the transfer, the pressure, that is all a very good explanation for the fossil record, but there was so much more to the flood than just the water. All right, other effects of the flood: landslides on a global scale. This is all massive landslides. Avalanches. I don't know if you've ever seen any video footage of what landslide does to houses and anything in its pathway down the side of a mountain. And that's a small, tiny scale compared to what would have been occurring during the flood. Mud flows, earthquakes, volcanic eruptions, and of course this one is important, tsunamis. All right, there was a large tsunami in Southeast Asia not that long ago. Massive destruction, but that was from a single earthquake and a single tsunami. Can you imagine? I guess we can't imagine. We can't even imagine what was happening to the surface of the earth during the global flood. All right, the Bible doesn't just say that the rains fell for 40 days and 40 nights. The Bible talks about the fountains of the deep being broken up. It was an extremely catastrophic event. Earthquakes, tsunamis, avalanches, mud flows, and so forth. So the flood itself was not just a rainstorm. All right? So we have to get that picture out of our mind. And of course, along with the flood, we are picturing a rainstorm, and it wasn't that. It was a global catastrophe, okay? And we also picture in our mind the little cartoon boat with the animals sticking out of it. Okay, now you know that's not the case, but it's still a picture that comes to people's minds due to entertainment and the idea that many times, even subconsciously, in our own Sunday school classes, we give the idea that we're telling a story. All right, when we're teaching on Noah's flood, are we telling a story? No, we are not. Okay, it's not a Bible story. It is an actual event that shaped the geological features of the earth. Okay, in my Sunday school class, I try not to use the word, it's time for the story, because I'm not telling them a story, am I? I am telling them what actually happened, and I'm trying to apply it to their life. Of course, I do have to entertain them a little bit, but I don't want to give them the impression that I'm telling them the story on the same level as my practical story that takes place, whether it's, we're talking a missionary story, all the other stories. Those are stories, yes, but the Bible lesson is not simply a story for entertainment purposes. So we have to get completely away from that. The flood was a real catastrophic event on a global scale. So we're going to go through some more predictions. Why? Because one of the best ways to show that catastrophism is superior in a scientific manner is to show that what we observe on the earth would have been predicted by the event that we call the flood. So predictions of a global flood would be, of course, everything we've seen in the fossil record. Both the formation of the fossils, the requirements for fossil formation are met very easily by the global flood. We have rapid burial on a massive scale, right? We have a lot of sedimentation that provides the minerals that we need for fossilization, and we have a lot of water that provides extremely high pressures to the surface of the earth. So what are the three requirements for fossil formation? Rapid burial in sediment, right? And then high pressure for compaction. The global flood would also predict the types of fossils, the location of the fossils, and the sheer number of fossils that we find. Sedimentation. If we had a global catastrophic flood, we would see a lot of sedimentation covering large areas, Do we see that? Absolutely. We see large uniform sedimentation across several states, even in the United States. And then we have evidence of transportation of sediments and animals over large distances. Remember, we could view the flood as a marine catastrophe. And that's exactly what we see, whether we're talking about the sedimentation or we're talking about the fossils, the types of animals and where they're found. So the global catastrophic flood is going to predict what we see in the fossil record and the amounts and types of sedimentation. All right. Also, what is predicted by the flood is multiple layers of sediment. And of course, the ice age. As far as strata goes, if we had a single catastrophic event that's going to lay down a big portion of the strata on the Earth's surface, we would expect those strata to be in layers, and we would expect that strata to display rapid deposition, and it does. The strata that we see at the Grand Canyon, which is a good example, because because of the canyon being carved, it exposes the different strata layers. So the Grand Canyon makes a good study for strata on the Earth's surface because of its large scale and because it's exposing it's about a mile deep. So we've got a mile of sediment that is being exposed by the Grand Canyon. And what do we see? What are the characteristics of those strata layers? Do they show that they were laid down gradually over millions of years, or do they indicate rapid deposition? Guess which one? Rapid deposition. There are two reasons why the strata appears to have been laid down rapidly. The first that you see on here is flat contact between the layers. If the layers were laid down gradually, they would have been exposed to wind and other types of erosion, and the borders between the different layers would not be so nicely horizontal and so flat. There's no evidence of erosion between the layers. So what does that indicate? They were laid down one right after the other. The other thing that we don't see in the strata is we don't see uniform composition. If those layers had been laid down gradually, there would be evidence of erosion on them, and there would be also evidence of weathering, and a lot of the particles that make up the layer would be smooth and more uniform in size. That's the exact opposite is the case. So when we look at the strata of the Earth, we see that it was deposited rapidly, one right after the other. So think about it. What's the best explanation? Millions of years, gradual, natural processes that happen all the time, or a catastrophic event that rapidly deposited those layers? What's the best explanation? Which model predicts what we see in the strata versus which model has to explain it away? And they are trying to explain it away. There's a compromise position, neo-catastrophism. What is neo-catastrophism? Well, we take the word catastrophism and we put the prefix neo on it. What does the prefix neo mean? It means new. Well, geologists are recognizing the fact that the features of the Earth have catastrophic evidence, that there were catastrophic events in the Earth's past. But they're unwilling to take it the next step and say, oh, it was the flood, just like the Bible says. No, they're not going to say that. But what they're going to do is they're going to have to accommodate, and they're going to say, well, there was a small catastrophe here, there's a flood over here. They're going to have to accommodate for it and make up small local catastrophes to try to explain away the features of the Earth. So the strata has evidence of rapid deposition. So that fits the catastrophe model better than the uniformitarian model, does it not? The Ice Age The Ice Age is something that you see promoted a lot in education and entertainment. And actually, the Ice Age, they have to find an explanation for it. We have a good explanation for it. Rapid cooling of the atmosphere that occurs after a catastrophe. We have evidence of this, of when we have these catastrophic disruptions on the Earth's surface, especially volcanic activity and so on, we are going to have a lot of sediment, and we're going to have a lot of volcanic ash spewed up into the atmosphere, and that brings about a drop in temperature. So we can explain the Ice Age that we see. We can explain those woolly mammoths that were buried alive in ice a lot better with a single global catastrophic event such as the flood than we can somehow coming up with different ice ages in our little cartoon, okay? So the recent case for catastrophism, this is where we have recent science, observed and documented science that supports the effects of catastrophe on the Earth. And that, of course, is the eruption of Mount St. Helens. Very recent in geologic time, isn't it? The 1980s. In fact, we are 36 years past the main eruption. So Mount St. Helens is located in Washington. It's between Olympia and, of course, Portland, Oregon. The main eruption that we're talking about when Mount St. Helens became an active volcano, the main large eruption occurred on May 18th, 1980. This was the largest volcanic eruption on the continental U.S. since the eruption in California in 1915. And then Mount St. Helens had another smaller eruption 2 years later on March 19th, 1982. Okay, here's a view, an old picture taken from an old panoramic camera of Mount St. Helens. Here it is. Here's the peak, taken from the north around 1979, a few months prior to that main eruption in 1980. Here's the same view taken in 1982. All right. And this photograph was taken after that second smaller eruption in March. Look at the devastation. This lake here at the base of Mount St. Helens is called Spirit Lake. There's also the Toutle River that flows into Spirit Lake, or used to. Now it's been completely dammed up, and the Spirit Lake is completely altered. And this, keep in mind, is a single volcano and nowhere near a global catastrophic event. Okay, here's the sequence of events. This was taken by Gary Rosenquist from 11 miles northeast of the peak. It's taken off of his camera. This is a 40-second time-elapse sequence of photos. I picked only 4 of them. Here is prior to the eruption at about 8:27 a.m. on the morning of May 18th, 1980. Then at 8:32 and 53 seconds, we see the first eruption of steam starting to come. And then a few seconds later, we have the catastrophic venting of steam and superheated air out of the side that completely blew away the entire north side of that peak. And then here is, this is 15 seconds after this particular picture, showing the main eruption out the side of the mountain. So here's the sequence of events on the morning of May 18th, 1980. Now there was a lot of forewarning that this volcano was going to erupt. There were multiple earthquakes prior to this time, but on the morning of the eruption in May, we had a 5.1 magnitude earthquake that began a rock slide. And what happened is the rock slide damaged part of the volcanic dome that was kind of the cap of the volcano. And so the first thing that happened was a rock slide caused by a 5.1 magnitude earthquake. Then the main eruption that I was talking about that occurred on the third photograph, all right, which you can see on this photo, that occurred, that's the northward lateral hydrothermic. That's steam, hydrothermic. Okay, we have a 5.1 magnitude earthquake that starts this debris avalanche. This removed what's called the cryptodome, which was kind of the cap on the volcano. And then we had this northward lateral, almost horizontal, hydrothermal explosion. And that, of course, initiates a massive avalanche and tidal wave on Spirit Lake. Okay, and basically what happened at the instant of this hydrothermic explosion, the 230 some square miles of forest was instantly stripped of all the branches and bark, and the trees torn out of the ground. We can tell that this occurred because not all of them, but millions of trees then were dumped into Spirit Lake. All of them were sheared off, leaving their roots in the ground. All right, so there again is the northward lateral blast, where most of the damage was done by the volcano. And this occurred again at 8:33 and some 3 seconds a.m. that morning. Here's the aftermath. Just a few things for you to see. Well, this again is, if you look at the bottom, this is all done by one volcano. Can you imagine the catastrophic events that occurred and the effects that they had on the earth if we're talking about the global flood and all of the events that occurred with it? Remember, it's not the rains came down and the floods came up. It was a global catastrophic event. So here's the aftermath of one volcano that has been observed and documented. 400 million tons of energy released that morning, May 18th, 1980. This, of course, we're talking about the lateral blast. We have 2/3 of a cubic mile of rock instantly pulverized and turned into volcanic ash and spewed up miles up into the atmosphere. Of course, this is the most destructive volcano in U.S. history, killing 57 people and causing $1 billion in property damage. Okay, and actually it wasn't in a populated area even, was it? And they had plenty of warning, so it could have been much worse. Then we have the idea that there was around 230 square miles of forest instantly scoured. And scour is a good word. Okay, so we have this initial blast of steam that occurred laterally out of the side of the mountain, not counting the earthquake and the landslide, but the main eruption was that lateral blast of steam coming out of the north face and just completely obliterating the north side of that mountain. That's where we have the 2/3 of a cubic mile of rock pulverized into ash, an ash cloud that's blasted over 16 miles up into the atmosphere. That's when we have the main destruction. Most of the 57 people killed were killed due to inhaling superheated air. Okay, of course, there were a few people, famous people even, that were killed. The one man, his name was Harry Truman, no relation to President Truman, that refused to leave his lodge or his cabin, and he was buried. I don't know if they ever found him or not, but all of this, we have that initial blast of steam releasing all that energy, estimated 650 mile an hour blast sideways out of Mount St. Helens. Okay, and it literally scoured the surrounding landscape. We have an ash cloud, kind of mushroom shaped, the stem of the mushroom being about 10 miles wide and the cap of the mushroom being about 40 miles wide. All done by one volcano. Here's the ash cloud. This photograph was taken 100 miles northeast of Mount St. Helens. Okay, and you are seeing once it has been dispersed in the atmosphere. So it was dispersed eastward at over 60 miles an hour, and within a very short amount of time, the ash cloud covered 11 states and several Canadian provinces. All right, there's pictures. You can take a look at pictures on the internet, I'm sure, and they were using snowplows to move the ash out of the streets in several surrounding areas. So this again is a lot of damage and a lot of alteration of the features of the earth right around that volcano. One volcano, and actually a relatively small eruption. Okay, say that wasn't small. No, it wasn't. But not nearly the size of the volcanic eruptions and the earthquakes that would have occurred with the flood. So here's some more pictures of the aftermath. Because we had all of the trees removed, where did they go? Well, they went into Spirit Lake, causing log jams and so forth. And here's a mud flow. This picture's taken many miles away. Some more pictures. These were taken a few days afterwards. You can see the clouds dispersed, so it's been some time. And it's completely scoured the landscape. This is Portland, Oregon, taken afterwards. There's the mushroom-shaped cloud. And here's a picture on Spirit Lake. You can see we have this floating mass of logs from the forests that were stripped. Further effects. We had, of course, volcano doesn't just erupt one time and be done. There's going to be smaller eruptions and earthquakes and all kinds of after effects. We had layers and layers of strata laid down on the afternoon of May the 18th, but we even had additional 25 feet of strata that was deposited in just 3 hours. And notice the date. We had another volcanic event taking place on June 12th, 1980. And the reason that this is significant is we can see the difference between the strata that was laid down on in May versus strata that was laid down in June. And what happened was we had mud flows. 2 years later, we had that additional eruption in March of 1982. Well, I guess not nice, but the interesting thing about that secondary explosion in March is, guess what? It set up mud flows that carved canyons out of the sediment that was deposited 2 years prior to that. So what does it do? It gives us a picture it gives us a window into the strata that was laid down by the volcano. So that's significant. We wouldn't be able to know what strata was laid down when if it weren't for the fact that we have the initial strata being laid down by the mud flows and the avalanche and water from Spirit Lake and steam and all kinds of things going on. Then we had an additional 25 feet laid down in 3 hours in June, and all of this was exposed from mud flows from another eruption 2 years later in March. So we were able to actually see a 140-foot canyon system carved out of the original strata laid down by Mount St. Helens. So this gives us a picture into what happens when we have a catastrophic event on the surface of the Earth. So we've actually got between anywhere from 400 to 600 feet of strata formed since 1980. 1980, that's 36 years ago. So did that take millions and millions of years? We also have some interesting things in Spirit Lake when it was investigated with sonar and scuba gear in 1985. 20,000 some upright trees buried in feet of sediment with their roots missing. Very similar in appearance to the petrified forest found in Yellowstone and the petrified forest found in Arizona. Then we also have this peat formed by all the stripped bark and branches off of all those millions of trees in that 230-foot square or 230-mile square bit of forest that was obliterated. And what? All in less than 50 years, kind of about 36, okay? So we already see a layer of what can become coal in less than 36 years. It doesn't take millions of years for the fossil fuels to form either. There's all kinds of lessons that can be learned from Mount St. Helens. Here's Stephen A. Austin. You can see that Mount St. Helens, he has studied a lot. He has several papers published on it and articles. It's a rare opportunity to study, look at this word here, transient geological processes. Transient. There and gone. Does that sound like uniformitarianism? Same processes, same rates? It does not. So within a few months, okay, or at most 2 years, we have sediment laying down, we have a canyon being carved. Of course, it's about a 1/40th scale of the Grand Canyon, but it's in 35 years. So Mount St. Helens provides good explanations. Here's the first conclusion. Strata layers form rapidly by flow processes, not gradual deposition over millions of years. That doesn't happen. Strata layers form rapidly due to flow processes from catastrophic events. It's not gradual deposition over millions of years. Here's the results from Mount St. Helens that have been observed and measured. 200 million cubic yards of material spewed out of that volcano in a matter of hours. 20 feet, 5 feet of strata formed in a few days. Erosion. Then remember, 140-foot canyon eroded by a subsequent eruption in 1982. So we have erosion, canyon system formed in a matter of days. We already have this canyon system. It doesn't take millions of years. And of course we have those polystriate fossils, in particular the petrified trees. We can see how the catastrophic burial in Spirit Lake mirrors what would have caused the petrified forest in Yellowstone and in the Petrified National Park in Arizona. So we see the upright logs in those petrified forests are better explained by the flood, because those trees would be that were stripped by the flood would be floating, much like the trees that we see in Spirit Lake after Mount St. Helens. So there's a picture of Spirit Lake. And here's that picture of that polystriate tree that I showed you the other day. So lessons from Mount St. Helens. Mount St. Helens, we talked about that ash cloud that spread over 11 states and several Canadian provinces, resulted in the cooling of global temperature by over 1 degree globally. Okay, so we have cooling can be a result of a catastrophe. We have rapid and coal forming and petrified wood forming in and around Spirit Lake. We have rapid sedimentation. We have rapid canyon formation by that subsequent eruption in March of 1982. We've got that little Grand Canyon, it's about 1/40th in size, that was carved out in a matter of days 2 years after that original eruption. We also see rapid soil and animal recovery. And here's my favorite one that's going to lead us into Thursday's lecture. We have new lava formation from 1980 and 1982. Dated by potassium argon. Very large, erroneous dates. We know that that new dome in Mount St. Helens crater had to have cooled in 1980. And it's been dated at 350,000 years plus by potassium argon. I think there's a problem with radiometric dating. So Mount St. Helens is a testimony to catastrophism on a small scale. Can you imagine global flood? Okay, this is Mount St. Helens recently. We still have, here's canyon formation. Of course, we're still missing, I don't know how many feet off the peak of Mount St. Helens. All right, so the case for catastrophism, prediction versus accommodation.